Hello students, in the previous episode we proved the formula of sigma n square and sigma n cube. Today we will study the application of this formula in the problems. First of all, we take a problem. Find the sum of three series up to n terms whose nth term is n times n plus 1 times n plus 5. So, in this problem the nth term is given to us. So, we have T n is equal to n times n plus 1 times n plus 5, which equals n cube plus 6 n square plus 5 n. We have to find S n. S n is sigma T n, that is sigma n cube plus 6 sigma n square plus 5 sigma n. From the formula we already know sigma n cube is n times n plus 1 by 2 whole square plus sigma n square is n times n plus 1 times 2n plus 1 upon 6 plus sigma n is 5 times n plus 1 by 2, which equals n square times n plus 1 square upon 4 plus n times n plus 1 times 2n plus 1 plus 5 by 2 n times n plus 1. This equals n plus 1 common, 4 also common, you get n square times n plus 1 plus n times 2n plus 1 plus 10 times n, that is n plus 1 upon 4 n cube plus n square plus 8 n square plus 4 n plus 10 n, that equals n plus 1 by 4 n cube plus 9 n square plus 14 n, which equals n times n plus 1 by 4 times n square plus 9 n plus 14, which equals ultimately n times n plus 1 by 4 times n plus 2 times n plus 7. This equals n square times n plus 1 whole square by 4 plus n times n plus 1 times 2n plus 1 plus 5 by 2 times n plus 1. Now, n plus 1 upon 4 is common. So, we get n square times n plus 1, 4n times 2n plus 1, then 10 times n equals n plus 1 by 4 n cube plus n square plus 8 n square plus 4 n plus 10 n equals n plus 1 by 4 n cube plus 9 n square plus 14 n, that equals n times n plus 1 by 4 n square plus 9 n plus 14, which equals n times n plus 1 times n plus 2 times n plus 7 upon 4. Now, this gives the final answer for the sum of the given series. Now, we take up another problem. Find the sum of the series 3 times 1 square plus 5 times 2 square and so on up to n terms. Now, this question differs from previous question in the sense, in this question the nth term is not given to you. So, first of all you have to find nth term. By mere observation we find that nth term is given by T n is equal to 2n plus 1 times n square. Hence, S n will be sigma T n equal to sigma of 2n plus 1 times n square, which equals sigma 2 n cube plus n square, which equals 2 sigma n cube plus sigma n square. We know the value of sigma n cube, so we get 2 times n plus 1 by 2 whole square plus n times n plus 1 times 2n plus 1 over 6. This equals 1 by 6 times n times n plus 1, 3 times n times n plus 1 plus 2n plus 1. This equals 1 by 6 times n plus 1 times 3n square plus 3n plus 2n plus 1, that is 1 by 6 n times n plus 1 3n square plus 5n plus 1. Now, this gives the sum of the n terms of the given series. Recall, in this question we have to first find the nth term and then we applied the sigma notations. The next problem is find the sum of the series 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on up to n terms. Here again the nth term is not given. Moreover, here the nth term itself is a series. For instance, here T n is 1 square plus 2 square and so on n square. So, the nth term itself is sum of some other series. So, we first find the sum and we know the sum already, that is n times n plus 1 times 2n plus 1 upon 6. Now, this is value of T n. We want S n. S n is sigma of T n, that is 1 by 6 sigma of n times n plus 1 times 2n plus 1, which equals 1 by 6 times sigma 2n square cube plus 3n square plus n, which equals 1 by 6 times 2 times sigma n cube plus 3 times sigma n square plus sigma n. This equals 1 by 6 2 times n plus 1 by 2 whole square plus 3 times n plus 1 times 2n plus 1 over 6 plus n times n plus 1 by 2. Now, throughout this we have n times n plus 1 by 2 common. So, it becomes 1 by 12 n times n plus 1. We have 1 by 2 n times n plus 1 plus 2n plus 1 plus 1. This equals 1 upon 6 times sigma of 2n cube plus 3n square plus n, which equals 1 by 6 times 2 times n plus 1 by 2 whole square plus 3 times n plus 1 times 2n plus 1 by 6 plus n times n plus 1 by 2. This equals 1 upon 12 n times n plus 1, n times n plus 1 plus 2n plus 1 plus 1, which equals n times n plus 1 by 12 times n square plus 3n plus 2, which equals n times n plus 1 times n plus 1 times n plus 2 over 12, that equals n times n plus 2 times n plus 1 square by 12. This is sum of the given series. Now we have one more problem of different type. We have the question to find the sum up to n terms of the series 3 plus 7 plus 13 and so on. In this problem, the difficulty is the nth term is not seen easily. So we have to first find out nth term with some trick. We assume Sn, that is the sum of n terms, to be 3 plus 7 plus 13 plus 21 and so on, and because we don't know the nth term, we write it as Tn. Now we subtract the same thing from Sn with a slight shifting the terms. So our 3 comes underneath 7, 7 comes underneath 13 and so on. When we subtract this, we get 0 is equal to 3 plus 4 plus 6 and so on up to n minus 1 terms minus Tn. Now the terms inside the brackets is an AP starting from 4 with a common difference of 6, and there are n minus 1 terms there. So it becomes Tn is equal to 3 plus n minus 1 by 2, 2 times first term plus n minus 2 times 2. This equals 3 plus n minus 1 by 2 inside 8 plus 2n minus 4, which equals 3 plus n minus 1 by 2 times 4 plus 2n, that is 3 plus n minus 1 times 2 plus n, that equals 3 plus n square plus n minus 2, that is n square plus n plus 1. This gives the sum of n terms of the given series. So we found that sometimes Tn is not given, sometimes Tn can be found immediately, and sometimes it takes some time to find Tn, but once we have found Tn, it is very easy to find Sn using the 3 formulae. Dear students, today we have completed the unit on sequence and series. In our 5 episodes, we have first discussed what is sequence and series, then we worked out formulae for AP and GP, and later on we found that there are some series which can't be covered by AP and GP. So we took some problems, some more formulae we derived, namely sigma n square, sigma n cube. With the help of these 3 formulae, we could attack almost all the problems involving series. And we found that at times we could not get the value of nth term directly. So we have to work out the nth term separately, and later on we applied the formula of sigma n cube, sigma n square, etc. This way we can attack any problem of sequence and series prescribed in your syllabus. Thank you.